Okay, we'll be going with the second paper. You can look into the first question. The first question is something like this. We need to find the equivalent resistance. So that's the first question. Maybe probably we can redraw the figure. When you redraw the figure, it is going to look like this. And you can see symmetrical situation, like when you rotate it about this point, you can see like the figure is symmetrical. So I can say like current in this will be same, and current in these three things will be same by symmetry. So once you understand symmetry, then it is going to be easy. So these three currents will be same, these three currents will be same. So by that I can conclude like if this is A, this is A, this is A, this also has to be A, because incoming current must be whatever battery giving, it will be receiving it back. Anyway, that doesn't matter much, I didn't use it much. Now this is connected to lower potential of the battery, this is connected to higher potential of the battery. So this is 0, and this resistance is same, this resistance is same, this resistance is same, current is same. So potential difference has to be same. So if this potential is X, this will be X, this will be X. Similarly, I can conclude if this is Y, this has to be Y, this has to be Y. So there are 4 potentials in the figure. I will be redrawing the figure 0, V, X and Y, and this is between V and Y, V and Y, V and Y. So 1, 1, 1 will be parallel, so 1 by 3. Similarly 4, 4, 4 parallel, 4 by 3. Then 3 2's and 3 3's are in parallel, then I will be getting 2 by 5, right? Because 3 3's are in parallel, you will be getting 1, 3 2's are in parallel, you will be getting 2 by 3, they are in parallel. So 2 by 3 into 1 by 2 by 3 plus 1, 2 by 5. Then equivalent resistance will be summation of this. That's all, right? Rope is placed like this. What is the acceleration? So I will be taking this part of the rope and I will be seeing what will be the force along the curved path. So I will be taking some element at an angle theta, its weight will be lambda into r d theta into g, its weight, but I need its component. So if this angle is theta, this angle will be theta, this will be 90 minus theta, so it will be sin theta, weight sin theta. Now I need to add all such components along the movement, right? So from where to where I will have to integrate, from 0 to alpha I have to integrate. So when I integrate, I will be getting this much. So that's the weight along this curve. Now similarly, if I take this path, yeah, this is alpha 1, this is alpha 2, right? So I need to find what is the difference. This side it will be lambda rg into 1 minus cos alpha 1, this side it will be lambda rg into 1 minus cos alpha 2. So the difference is going to be, yeah, this minus this, right? Weight difference, I mean component, this component force we have calculated, this component force we have calculated, the difference equals to mass times of acceleration. Mass will be lambda into total length is r alpha 1 plus r alpha 2. This is the total mass into acceleration. Net force equals to total mass into acceleration. From there I will be getting the acceleration. The next one, a stream of particles are coming and there is a small hole of diameter. Then the beam, what will be the diameter of the beam, and I am not sure like what they are doing in the solution, Heisenberg's certain principle, whatever like you can refer. But we know like when there is a circular aperture and if there is diffraction happening, then the radius of the image will be making an angle theta, and that theta will be given by sin theta is 1.22 lambda by b, where b is the diameter of the hole. So if I go with that explanation, then the diameter of this thing is going to be like when these angles are small, then this length is going to be L into theta. So this length is L into theta, radius is L into theta, so this one also L into theta, so diameter will be 2 times of L into theta. Now theta is almost 1.22 lambda by diameter d naught, right? Lambda is h by mv. So this is going to be my answer, but it has nothing to do with the, I mean they are asking estimation and they have given none of this also in the answer. So I don't think we can understand how to approach it unless they mention something in the hints. There is a droplet of fluid like donut in shape. Find the radius of curvature at point B in the plane perpendicular to the paper. So like donut is going to be like this. Now if you look at the inner part, now this blue line, that blue line is the inner circle thing that has one radius, and outer blue line that has other radius, this outer radius. Now if you look at the inner part, that blue color thing has one radius and this green color thing has one radius. Now similarly, if you look at the outer part, that blue color thing has one radius and the green color thing will have one radius. Now in this particular figure, they have given, I have copied the figure where this radius of curvature looks same as this radius of curvature, but they are different in this case. So when I look from top view, it is going to look like this. This inner one has some radius of curvature which I am calling it as R1. This outer one has some radius of curvature which is R2. Now apart from that, now this green color thing has some radius of curvature. So you can see this part has some radius of curvature. I am calling that radius of curvature as R1, and this part has this outer part. This outer part has some radius of curvature which is small r2, small r1, small r2. Now if I look at outer part, now for this outer part there are two radius of curvature. This is one radius of curvature r2 and this is one radius of curvature small r2. Now if I take this radius of curvature, center is going to be this way. So if I look at the pressure difference between these two things, pressure difference because of this radius of curvature. So radius of curvature is this way. So if this pressure is P0, then the pressure here will be more because the surface is like this. So P0 plus T by R2. P0 plus T by R2. P0 plus T by R2 because of this curvature. Now if I take because of this curvature like this pink color thing, that curvature is going to be like this, again center is inside it. So again the pressure because of this curvature is going to be more here. So P0 plus T by small r2. So due to bigger curvature it is T plus T by capital R2, due to smaller curvature T by small r2. But if you look this one, if the pressure here is P0, now this green curvature is this way. So when you go from here to here, the pressure will decrease because of this curvature. So P0 minus 2T by T by capital R1, because this curvature center is this side. But if you look at the pink color curvature, it is like this, center is here. Now because of this curvature, what will happen when you go from here to here, pressure has to increase. So plus T by R1, P0 minus T by capital R1 plus T by R1. Right, so from there you will be solving it. Now how you got that formula? Pressure difference has to be T by R1 plus T by R2. There will be some derivation. You can, if you want, you can look at the derivation. So it's like that Aladdin mat and stuff, right? So there are two radius of curvature. This radius of curvature is R, this radius of Rx, and this radius of curvature is Ry. So in the same as in the previous case, there will be two radius of curvature. For a sphere, both radius of curvature will be R and R only. For a cylinder, one radius of curvature will be R, one radius of curvature will be infinity. In the previous question, there are different values. Right, so you will be drawing the free body diagram, you will be making net force equals to 0, and you will be ending up with pressure difference equals to T by R1 plus T by R2. Now those radius of curvature has to be perpendicular, like this is along one side and this is perpendicular to the other side, it's like this. So this radius is along one surface and this radius is perpendicular to whatever we have taken earlier. So what is the radius of curvature of at B perpendicular to the plane? So that is this small r2, perpendicular to the plane, the radius of curvature is r2. In the next case, initially there is some mass here and it is in equilibrium and this height is h0. So if it is in equilibrium, then the pressure here will be 3g by A when you make net force equal to 0 on this. And the volume is, if I take the base area as A, then the volume is going to be A into h0, temperature is T0, number of moles are not going to change. When you put some extra mass, what will happen? Like it will keep going down and like some oscillation will be happening, and finally like it will be settling down. Once it settles down, then the weight will be hg, so the pressure here will be hg by A. So now temperature is going to change, volume is going to change and stuff. So AH1, this height is h1, so the volume will be AH1 and that new temperature is T1. Now generally we can't apply PV power gamma is constant because it's not reversible. PV power gamma constant is applied only for reversible process, though we apply at some places unless until like we don't have any other option. But here we can see there is a drop in potential energy. When you put 5 kg, that entire 8 kg is coming down. So there is a drop in potential energy that must be going as change in internal energy of the gas. Drop in potential energy will be going as change in internal energy of the gas, right, from here to here. So from there H0 and H1 I am writing in terms of like nRT by PV equals to nRT you can use, and you can find what is H0 value, H1 value, and you can just substitute it here and you will be getting the answer. Now from here to here also, like when I am removing it, there is 3 kg which is going up, so there is a increment in potential energy that will be going as drop in internal energy, right. Drop in internal energy will be going as increment in the potential energy. Again H2 and H1 I can calculate using PV equals to nRT and I can substitute it, right. In the next question, there is a regular tetrahedron which is completely immersed. So the first thing is, one tetrahedron is like 6 tetrahedrons will be making one full parallel pipe. So volume of tetrahedron will be 1/6 of volume of parallel pipe, which will be like this much. Volume of tetrahedron will be a cube by 6 root 2. Once you know that, if you want to find what is the net force because of water, it will be given by only volume submerged, density of the liquid into volume submerged into G. Now at the base pressure will be rho G H. If you neglect the atmosphere, this will neglect the atmospheric pressure, right? Yes. So pressure here will be rho G H into base area. Rho G H into base area will give us the force on the base area. Net force on the body we know. At the same time, we know force on the base. So what will be the force on the remaining 3 surfaces? It is going to be this. We know the net force, we know the force on the base, so we can calculate the force on the remaining 3 things. That will be only subtraction, right? So this minus this minus this. Force on the base in the upward direction, force on the remaining faces will be in the downward direction, but the net we know as density of the liquid into volume submerged into G. So force on the remaining 3 faces will be this much, we can calculate. Now force on the remaining 3 faces will be symmetrical to each other. So on the first face, the force will be perpendicular to the face. On the second face also it will be perpendicular. On the third face also it will be perpendicular. The resultant will be in the downward direction. So F, if it is making angle theta with a vertical, F cos theta, 3F cos theta. So 3F cos theta will be equals to the force which we have calculated already. See what we have calculated, what is the net force by the liquid, thereafter we have calculated what is the force on the base, thereafter we have calculated what is the force on the 3 sides together, then 3 sides together in the sense F component, 3 sides together. Now that cos theta, I didn't attach it, I think maybe you can do it by yourself. What is the angle made by the area vector of the side with the vertical? So that will turn out to be 1/3. So when you substitute, you will be getting the required answer. So in the next question, there will be current flowing. Now because of the current is flowing this way, magnetic field is there. So B bar, L bar cross B bar. So there will be rotation, there will be torque, there will be rotation. So if there is rotation, then there will be, current is flowing this way, L bar cross B bar, force will be this way, so it will be rotating this way. If it is rotating this way, then V bar cross B bar, so there will be induced EMF in this direction, Now how much is that? Half into B omega into R square, right? Yes, if some current is flowing, then L bar cross B bar, force on different element will be different thing. So we need to apply torque, we need to integrate it to get the torque. So fine. So let us calculate what is the torque. If some current I is flowing, so I will be taking some element here. Now what will be the force on that element at a distance x? If this length is dx, force on that element will be I into dx into b. So force is I into dx into b into this distance. That will give us the torque. If I integrate, I will be getting the total torque. Now I need to get omega at any time. So torque dt will be, we will see this later. When we write the loop equation, B minus L di by dt minus half B omega R square equals to 0. Now I need to solve this. Solving this is omega is varying with time. So I think that's the reason we need to calculate omega. How to calculate omega? Omega is torque dt. Torque dt is change in angular momentum, right? So torque we have calculated, torque dt we need to calculate. So which will be this, torque dt is I omega. We need to find omega and substitute it there. Finding omega is difficult because we don't know I. We need to integrate. So what I can do, I can differentiate this equation. So like Leibniz rule or something, right? So when you differentiate, you will be getting I at t minus I at 0. I initially was 0. So d omega by dt I can get from here. So if I can get d omega by dt, if I want to use it here, I can differentiate this equation, and d omega by dt I got from here. So I will be substituting there. D omega by dt I will be substituting here, then I will be getting single variable. So first of all, we will be writing loop equation to solve the question, but there are 2 variables, we need to convert this into single variable. Now we will see why omega, how omega is depending on I. So for that we will be going for torque. That doesn't give us anything. Torque dt will give us something, but that also we can't do because integration is there. So we will be differentiating it, as we got only d omega by dt, we will be differentiating this equation and we will be substituting it. Now this is going to look like SHM, something double dash equals to minus omega square into something. So if it is of SHM, then general solution is going to be p sin omega t plus q cos omega t. Now there are two variables, so we need to know two initial conditions. I am just differentiating it. Differentiation of this one is going to become p omega cos omega t minus q omega sin omega t. At t equals to 0, current is 0. At t equals to 0, di by dt. At t equals to 0, di by dt. Omega is 0, right? So di by dt is v by L. So t equals to 0, current is 0. This is 0. This is q. This is v by L. This is p omega, this is sin thing is 0. So from there I will be getting q value is 0, p value is v by omega L. So I can just substitute it back, p value is v by omega L, q value is 0. So current as a function of time I got. So once I get current as a function of time, what they are asking, when the current will be becoming maximum for the first time. So when it will be becoming maximum for the first time, like it's like SHM where it is at mean position. When it will become maximum at the first time, t by 4. So t will be getting omega we got, so t will be 2 pi by omega, but after how much time it is becoming maximum? T by 4. So we need to calculate only t by 4, which will give us option B as correct. Now they are asking what is the average kinetic energy. If I want to find average kinetic energy, I need to find omega. If I want to find omega, this equation we have already got here. We need to do integration IDT. So for finding integral IDT, I know, so integral IDT from 0 to t will be this thing, right? So always IDT, integral IDT will be that thing, whatever we got here. Now that is I omega, but I need to find kinetic energy. Kinetic energy is half I omega square, so I can write it as L square by 2y. So this square by 2y. This is the kinetic energy, but I need to find average. Average of these things will be same as it is. Now this one will have, it is a plus a minus b whole square, so a square plus b square minus 2ab thing, right? So 1 square average will be 1, cos square average will be half, and minus 2ab, that average is going to be 0 because it is cos. So 3 by 2, I can just substitute it, and this omega power 4, omega value we know from here, we can just substitute that omega value and we can get the required answer, right? Something is moving in circular motion, you are just changing the direction so that it will move in elliptical motion. So potential energy is same, kinetic energy is same, so total energy is going to remain same. If total energy is going to remain same, then the major axis of the ellipse and diameter of the circular thing is going to remain same, or semi-major axis of the ellipse and radius of the circular orbit is going to remain same. Okay, fine. So it is going to perform ellipse. Now what all information they give? Radius information is given. So if radius information is given, semi-major axis must be radius, so major axis must be 2 times of radius. Okay, fine. Now nearest point is at a distance 8 into 10 power 7. Nearest point is at a distance 8 into 10 power 7. This is farthest point, this is the nearest point. So this is 8 into 10 power 7, but the total we know it as 2 times of radius, which is 8 into 10 power 8 or 80 into 10 power 7. Total is 80 into 10 power 7, this is 8 into 10 power 7, so the remaining will be 32 into 10 power, 72 into 10 power 7. 80, yeah, out of 80 this will be 8 into 10 power 7, so this will be 72 into 10 power 7. So this I can write it as a into 1 plus 1 minus a into 1 minus a, this is a into 1 plus e, you people must be knowing it. This will be a into 1 minus e, this will be a into 1 plus e. From there when I take the ratio, I will be getting what is the value of e. That's more or less like math. They are asking what is the ratio of VB to VA. So I can do angular momentum conservation, right? So the angular momentum here must be same as angular momentum here. Yes, right. I could have done that, right? VB to VA. Oh, sorry. VB to VA. So there is a problem here. If it was angular, if it was here and here, then I could have done angular momentum conservation, because while doing angular momentum conservation, no angles will be coming into picture. It is 90 degrees. So I need to find velocity here and here. So here potential energy we know, and kinetic energy, yes, we know. Total energy we know, right? So total energy here must be same as total energy here. This velocity we already know because it was performing orbital motion, right? Root of gm by that radius. So this one we know. Now this energy will be how much? Yeah. Potential energy plus kinetic energy will be minus gm1 m2 by 2r. 2R. So the energy here must be same as energy here. Here potential energy is minus gmm by this distance, and kinetic energy will be half mv square. Energy here equals to energy here I have equated, and I got the velocity as this much. Velocity here I got. Velocity here is this much, and velocity here will be, it was already performing circular motion with some velocity. What is that velocity? Root of gm by this one. Now you are just changing the direction, you are not changing any magnitude. So what was the velocity here? Root of gm by this thing. So this is the velocity at A, this is the velocity at A, this is the velocity at B. So velocity at B by velocity at A is 3, right? Okay, next one is electromagnetic wave. You must have seen this kind of question in mains also. Now that is the information given. From there we can predict what is the direction of, we can see what is the direction of motion of the ray, right? So that is I cap plus 2j cap plus 3k cap by its magnitude. That is the unit vector. That is the unit vector. That is the direction of ray propagation. Electric field direction will be given by, I just want to find unit vector. So I am dividing with the magnitude. Anyway, that is not needed. I am just doing it for myself. Now I know these two must be perpendicular. I know E, C, B, all these three directions must be perpendicular, right? And E bar cross B bar must be in the same direction as C bar thing. Okay, fine. So these two have to be perpendicular, so the dot product has to be 0. From there I will be getting B value as -2, but in the options they have given it as 2. Now speed is given. Speed is given 3 into 10 power, right? Now, this magnitude thing, it is like k bar dot r bar you will be taking, right? You can look at it as a solution, you will understand it anyway. So it's like kx minus omega t, but here it is k bar dot r bar minus omega t. So that k, you need to, k is 2 pi by lambda, this is 2 pi by t, so you need to divide this by this by this, omega by k, right? So omega by k, magnitude of this thing is, anyway 10 power 7 will get cancelled in both the things, so I did not write here 10 power 7. So from there we will be getting root 14 into Cc is 3 into 10 power 8. Now amplitude of magnetic field, B value we got. Once you get B value, then you know what is the amplitude of electric field. Once you know amplitude of electric field, then amplitude of magnetic field will be E0 by C, E equals to Cb, right? So amplitude of this B value is 2, so magnitude is root of 3 square plus 2 square, which will be root 13 into 10 power minus 3 by C value. So from there we will be getting what is the magnetic field amplitude. Now energy density, because of the for the total wave. For the total wave it will be half epsilon naught E square. Due to electric field it will be half epsilon naught 1 by 4 epsilon naught E square. Due to magnetic field, magnitude wise it will be equal to 1 by 4 epsilon naught E square. Total will be half epsilon naught E square, half epsilon naught electric field square. Just now we have calculated the value, right? This is 3, this is 2, magnitude will be root 13 into 10 power minus 3. So 13 into 10 power minus 6, this is square. Okay, there is a conducting loop and stuff. The loop is in YZ plane and magnetic field is along Y axis. So the loop is in YZ plane and the magnetic field is along Y axis. Now the loop is rotated slightly by an angle theta and leaving it. So what will happen? There will be some kind of SHM thing. So when you rotate it and leave it, now there are some strings connected here and here. So suppose if there is no magnetic field, if you are rotating and leaving it, those strings, because you are rotating by angle theta, there will be opposite torque k into theta, so it will be rotating it back. Now there is extra magnetic field. So when it is rotating, what will happen? There will be change in flux because of magnetic field. If there is change in flux because of magnetic field, there will be torque coming into picture, right? Okay, so that's the thing. Now there will be two torques. What are those two torques? When you are moving it this way, like it will be performing SHM because of the torque because of the strings, and there will be extra torque because of the magnetic field. So flux will be like when it is rotating at certain instant, when it has rotated by angle theta, then the flux is going to be how much? When it has rotated by angle theta, area vector, what is the area vector direction? Area vector is in this direction, so angle between them is 90 minus theta, so flux is going to become B into A into cos 90 minus theta, which will be sin theta. Flux is this much, so rate of change of flux will be BA into cos theta, and that theta is not constant, it is varying, so theta dash, that is EMF. If I know EMF, if I divide with resistance, I will be getting current. So I need to find torque, so I need to find magnetic moment. Magnetic moment is I into area. I into area. So torque will be how much? Torque will be m bar cross b bar, m bar cross b bar, m bar cross b bar, I mean mu bar cross b bar, mu into b into sine of angle between them. Now, okay, when it was rotating, so flux is increasing. If flux is increasing, then there will be induced EMF in this direction, So magnetic moment will be in this direction. So angle between them is going to be, magnetic field is in this direction, magnetic moment is in this direction. So theta plus 90, 90 plus theta. So mu bar cross b bar will be like mu into b into sin 90 plus theta, and all the things current we have calculated already. I am just substituting it. So basically you will be getting torque because of magnetic field is this much. So magnetic moment is in this direction, magnetic field is in this direction, so torque is in this direction. So both this torque as well as the string torque, both are in the same direction. So net torque is going to be string torque plus magnetic field torque, that equals to I into alpha in the opposite direction. Theta is in this direction, torque is in the opposite direction. Now for small angles, then this theta is going to be almost 1, and these values were given in the question, b square a square by r, which when you substitute you will be getting it as 1. So basically you will be getting this equation. So we need to solve this equation. So that's the thing. So we will see in the end how to solve this equation. This is not a simple equation for us to solve, it is like a damping equation, right? We will see that later by the end of the session. In the next case, they said a charged particle is, so a charged particle of charge q is released from here and you are slightly disturbing it. So the time taken from here to here is t0. Now you are putting some charged particle which is 4q and you are leaving it. So what is the time taken? So basically they didn't give anything. Initial velocity is 0 in both the cases, and acceleration will be different because the forces are different. How much difference the force will be? Here this distance is remaining same, but the charge is becoming 4 times. So force is going to become 4 times. Individual forces are becoming 4 times, so component is also going to become 4 times. Okay, and the distance traveled is same. So by dimensional analysis you can get, like it has to depend on initial velocity, acceleration and like distance travel, but initial velocity is 0. So obviously time has to be dependent only on the acceleration and distance travel. Distance traveled is same, but acceleration, if you look at the first case, if it is here, and in the second case if it's at the same point, then the forces are going to be exactly 4 times. If the forces are going to be exactly 4 times, then the accelerations will be exactly 4 times, right? So in the first case if the acceleration is a, in the second case it will be 4a. So by dimensional analysis, s equal to ut plus half a square, or by dimensional analysis like if it depends on only acceleration and d, it has to be like proportional to root of d by, so root of d by a, root of d by a, anyway d is same, so time will be inversely proportional to acceleration. So you will be getting that ratio and stuff. So the only thing you need to understand is they are going with the dimensional analysis because d is same and acceleration is different. There is no other way. In the next case, you are throwing something with velocity u. By symmetry, you can see like it will be going with velocity u. Finally, it will be attracted. But like it won't be attracted to the earth. They already said it will be going to other point again. So the deviation. So this is the initial ray, and this is the final ray. So the angle, how much it has deviated? Theta. So you need to calculate what is that theta. So you will be extending this ray, and wherever they will be meeting, like if you join this line, that is going to be like symmetrical line. That must make sense, obviously. Now there is change in momentum happening if this velocity, initially potential energy is 0 and kinetic energy is half mv0 square. So finally also potential energy is 0, so kinetic energy has to be half mv0 square. So if the initial velocity is v0, final velocity also will be v0. Now what is the change in momentum? Change in momentum I can calculate. This momentum is mv0, this momentum is mv0, and the angle between them is theta. So change in momentum is like the vector quantity, right? So you can do the change in momentum, which will turn out to be this much. Change in momentum will be in this direction. I have taken this as m cap. Change in momentum will be in minus m cap direction. That must make sense because force will be in this direction only, right? Resultant of this force and this force will be in this direction. So why is that change in momentum happening? Because of the force, but force at different places are going to be different. So what I can say, integral. Now if I take any random position at an angle phi, the force here will be in this direction, but this force is not needed for me because change in momentum is happening only along this direction. So this force, only this component, this force cos phi, that force cos phi dt will give me change in momentum which is happening in this direction, right? But there is a problem, this phi is varying with time, this f is also varying with time because this force depends on this distance, the distance is varying with time. So these two are varying, I can't integrate it. Now if I want to integrate this, I need to take some other help. Now I know in gravitation we have to use, we can most probably will be using conservation of angular momentum, and whenever it is at very far distance and this length is given, then obviously if this length is given we have to do something with conservation of angular momentum. So initial angular momentum is b into m into initial velocity 2. Now at any moment velocity will be in some random direction, but if you want to find what is the velocity, see, if you take here the force is in this direction, velocity is in this direction, so the angle is not 90, but this velocity will have two components, one is perpendicular to the line joining, one is along the line joining. If I want to find the velocity perpendicular to the line joining, angular momentum will be because of only this one. Now if I want to find velocity in the perpendicular direction, then I can write it as omega bar cross r bar, Here also I can write it as velocity perpendicular to this as omega bar cross r bar. This one I can write as omega bar cross r bar, and I can write the same thing as omega into r square. Now from there, see, the problem is this thing, the force I can write it as this one. Now the problem is there are many variables, cos phi, this is varying with time, this is also varying with time. So I need to convert these three variables into single variable form. So for that I am using this information. This omega is nothing but the rate at which this angle is varying. So till here we will be getting. Now this is the first information, why is there momentum change happening, angular momentum conservation, but I need to eliminate these three variables into single variable form. So for that I am writing this as d phi by dt. Now I can see r square by dt is coming into picture, so I can eliminate r square by dt. So dt by r square I am getting it as d phi by 2b. dt by r square I am getting it as d phi by 2d. Now I can see it as single variable. Now that's all, you need to integrate. So initial value of phi you can calculate geometrically, and it will turn out to be like varying from pi minus theta by 2 to pi plus, this angle is going to be pi minus theta by 2, so this is minus and this is plus, so you can do by yourself. Then you will be getting the required answer, and you must have seen the same thing as in modern physics, like scattering angular stuff, right? So what all things you need to use? Momentum change, why is momentum change happening, force, and conservation of angular momentum. In the next case, something is released under gravity, wind is blowing. Due to viscosity, there is a force where v is the velocity of object with respect to wind. Okay, so we need to observe from wind frame. When you observe from wind frame, wind is moving in this direction, so when you observe from wind, this will be having velocity 4 and gravity is in the downward direction. So velocity is in this direction, so viscous force will be in the opposite direction. Now because of this, what will happen, vertical velocity will increase, because of this it will try to move in the horizontal direction, but vertical velocity will reduce. Because of this, horizontal velocity will reduce, vertical velocity will increase, horizontal velocity will reduce, so it will be curving. So at some random moment it is going to be like this, weight will be in this direction, velocity will be in this direction. If the velocity is in this direction, then viscous force will be in the opposite direction. You can see like horizontal component is always it's always reducing because of this viscous force, but vertical velocity it's not, mg is trying to increase this vertical velocity. So what will happen after long term, this horizontal velocity is going to become 0, there will be only vertical velocity. Now after some time, like you can manage by yourself, there will be two forces, mg and kv. Now suppose when it becomes vertical almost, if mg is greater than kv, what will happen, velocity will keep increasing in the downward direction. So velocity will increase and kv will increase, and so let me say mg is more and kv is less. Now what will happen, velocity will be keeping on increasing and this will be keeping on increasing, and they will become equal. If kv is more and mg is less, what will happen, velocity will be reducing, so this will be reducing and they will become equal. So once it attains terminal velocity, mg will be becoming equal to kv. mg will be becoming equal to terminal velocity in wind frame, so which is 3. In wind frame it is 3, so when we go to ground frame it will be 3 plus 4, right. A very long cylinder is rotating with angular velocity under mutual gravitational interaction. I think this kind of question was there for sphere in PYQs, right. So there is a cylinder of dust which is rotating, and if I take any particle here, it is performing circular motion under the mutual gravitational attraction. So if I take some particle, I need to write net force towards the center equals to m omega square r. So if the field there is some E, let me talk in terms of electrostatics. So if the field there is E, then okay, let me talk in terms of gravitation only, fine. So field in electrostatics is similar to small g value here, right, or yeah, field intensity is defined gravitation also, okay, fine. So mass into field there will give us the force there, mass into field there will give us the force there, that force must be sufficient for centripetal to act like centripetal force. So that force, gravitational force, must be equal to m omega square r. So from there we will be getting what is the field needed there, what is the field needed there, it will be omega square r form. Now by taking Gauss law thing, now in Gauss law, Gauss law is related to field, right. So kq by r square is similar to gm by r square. So kq is similar to gm. So q by epsilon naught is similar to 4 pi gm, 4 pi gm. So if you want to use similar Gauss law, so that is flux through a closed surface, then we need to use that is equals to 4 pi into g into mass enclosed, mass enclosed. So if I take Gaussian surface for this yellow color thing, so flux through the curved surface will be E into curved surface area 2 pi RL, that equals to how much, 4 pi into g into mass enclosed, 4 pi into g into mass enclosed. Mass enclosed, the density is keeping on varying, so what we will do, we will take some element here, of radius x, and we will be finding what is the mass, there will be density into volume there. Now surface area will be 2 pi x into L, and thickness will be dx. So density into volume of that element. We need to find what is the mass inside this yellow thing, so we will be taking another small element, so we will be finding mass of that element, and we will be integrating from where to where, 0 to r. Now from there we will be getting the electric field, right. Oh yeah, I think I have done something wrong here. It is E into r, I need to differentiate it, but while differentiating I have taken E as constant, which is not constant, it is proportional to r. So this is omega square r into r, so it will be omega square r square. So when I differentiate it, I will be getting 2 times of r here, So this r and this r will get cancelled. Yes, this r and this r will get cancelled, so density is constant I will be getting, yeah. So density is constant. I think this method was wrong, So this electric field, we need to this electric field is a function of r, so we will be getting omega square r into r, omega square r square. I need to differentiate it on both sides, so here I will be getting omega square into 2r, Here differentiation will be rho at r into r, rho at 0 into 0, so this will be 0. Here we will be getting r, here we will be getting r, this r and this r will get cancelled, so density will be going to be constant. This is wrong, but density is going to remain constant. So ratio is going to remain 1, right. So a rod is moving from here to here, you need to find what is the work done, and coefficient of friction is different in both the cases. So if I take some element at a distance x, and this mass density is varying, so this mass is going to be how much, lambda there into dx. Okay, now it is going from here to here, So how much distance this is traveling? It is traveling L minus x in mu and x in 2 mu. L minus x in mu and x in 2 mu. So what is the work done by friction from here to here? It will be friction, coefficient of friction, maximum friction, right, mu into m into g, and distance travelled here is L minus x. Now from here to here, magnitude wise we are calculating 2 mu into m into g, that is the friction, into distance travelled here x. So what is the work done by friction magnitude wise when it goes from here to here? This much plus this much, plus this much. Now we need to integrate it. that's for one element. So if I want to do for all the elements, I need to integrate from 0 to L. Now that lambda is depending on x, so lambda naught into x. So this is the work done for that small element. So if I integrate, I will be getting total work done. Total work done is this much, but they gave in terms of total mass. So first of all, we need to calculate total mass. Total mass will be lambda. This mass is lambda dx. So if I integrate, I will be getting the total mass. Total mass is this much. So I will be dividing with the total mass, or this is total mass. So you will be getting this as the answer. Okay, parallel beam of rays are coming, and what must be the minimum thickness? What must be the minimum thickness so that all these rays will be coming from this side, right? So we need to make sure only this ray, if it is not going back, then the remaining rays won't be going back. So if this ray, we can make sure this is total internally reflected back and it is coming here, then all the rays. Now when you make this one here, what will happen? Okay, let me go with this one. So what is happening to the angle of incidence is going to become almost 90, right? So if this is going to be more than critical angle, then all the angles here are going to be critical angles. So all these rays which are passing here, they will be like undergoing total internal reflection and they will be passing through this thing. So that's the only thing. So this ray has to cross this and it must come here. So from there you can take this triangle and you can use sine critical. This must be just greater than critical angle at least, right? So you can take this as critical angle. So sine critical angle equals to r by, now this is r, this is r and this is d, right? So this is r plus d. So sine critical angle equals to r by r plus d. So from there you will be getting the required answer. The only thing you need to understand is this ray has to sufficiently come through the remaining part. In the next one, there is a segment of ring, you are moving it and leaving it, so it is performing SHM. So you will be writing torque equals to I alpha and you will be looking at it like SHM equation, right? So when you are rotating it by small angle alpha, now the only thing you need to understand is the remaining part is going to look the same, and this part you can feel like initially from here to here it is there. Initially A to, okay, initially from A to B it is there. Now when you are rotating, it will go like this. So from the previous situation to this situation, what you can see is this part is disappearing and it is appearing here. So initially it is from here to here. Now when you are rotating it, this part is disappearing and this part is coming here. So this part will be compensated by this part. This is the only uncompensated part. Now what is the length of uncompensated part? This angle is alpha, this angle is alpha. So this length is r into 2 alpha. So weight of uncompensated part is lambda into r into 2 alpha into g. Now that torque will be this component. This component won't give torque, only this component will give you torque. So r into this mg sin theta component, sin alpha component. This angle is almost 5 by, these angles are small, so 5 by 2 you can take. So this will be making with this one, it will be making 5 by 2. So this component will be cos 5 by 2, this component will be sin 5 by 2. So torque will be r into this sin 5 by 2, r into this sin 5 by 2. Torque equals to I alpha, moment of inertia of any part of the ring. Now all are at equal distance r, so moment of inertia will be mr square. Torque equals to I alpha. Now m is total mass, is mass per unit length into this length, which is mass per unit length is lambda and this length is r into phi. So from there you can see this, you are moving it by alpha, so angular acceleration will be alpha double dash magnitude wise, right? Now you can see alpha double dash is proportional to alpha, so it is going to be SHM. So this is going to be omega square, x double dash equals to omega square x form, right? So time period will be 2 pi by omega, but what we need only time period, right? Yes, so we need only time period. From there you can get the answer. All you need to understand is, for easy calculation, this mass is disappearing and it is appearing here, and the uncompensated mass is this much, whose length is r into 2 alpha, which is lying at an angle 5 by 2 almost. A closed argon pipe is there. It is vibrating in first overtone with tuning fork F, and the length of the air column is 96. Now the tuning fork is replaced by another tuning fork. Then what must be the minimum distance shifted so that again standing wave is formed. So they said first overtone, so it is going to look like here there will be pressure maximum, here there will be pressure minimum, and it is going to look like this. So lambda by 4, lambda by 4, lambda by 4, 3 lambda by 4 is 96 given in the question. From there we will be getting lambda. You can use V equals to lambda F. Okay, V is same in all the cases, but frequency is becoming how much? Frequency is becoming 32 by 15 times of this thing. So wavelength is wavelength we can calculate from there, right? So I am just checking for what length fundamental will happen. For fundamental, like only lambda by 4 will come into picture, right? So lambda by 4 equals to length. So I will be varying this and I will be seeing where the fundamental will be happening for the second frequency. So lambda by 4 equals to L. Now lambda into F, lambda into F must be equals to velocity, right? So this velocity must be same as this velocity. So I will be getting what is the new lambda. New lambda will be like 60, you can get from here. I am checking where the fundamental will happen. So lambda value I have calculated from here and I have substituted. So fundamental will happen for this length. Fundamental will happen for this length, that is lambda by 4. Lambda 2 by 4 is 15. So next one will happen at 3 lambda by 4. Next one will happen at 5 lambda by 4, 7 lambda by 4. So lambda by 4, 3 lambda by 4, 5 lambda. This is fundamental, first overtone, second overtone, third overtone, and so on. So initially the length was 96. Now I can reduce the length to 75 or I can increase the length to 105 for standing wave to be found, but which is more easy for us? 96 to 105, the only difference is 9. But if you want to move to 75, the difference is 21. They are asking what is the least distance, which is 9, right? Now going to the other question, what we have left, the damping question. Okay, before going to damping question, yeah, you can see this is like SHM. Now by guess I can say like P sin omega t is a solution of it. Like when I substitute it, I can see like it is matching. It is matching minus omega square into x1 form. So this is a solution. Now similarly I can guess this can also be a solution. This can also be a solution. Then what is the solution? Whether this is the solution or this is the solution. The general solution, these are specific solutions. The general solution is going to be when it is a double differential equation, there will be there will be two roots. So if you can find any two roots, then the summation of it is going to be general root. So the general solution is going to be P sin omega t plus Q cos omega t. Now why the summation is going to be general solution? Because you can see if this is the solution, this is first one, right? And this is the second one, I can add them and I will be getting this equation. This same equation I can write it this way. So the meaning is if x1 and x2 are solutions, then x1 plus x2 is also a solution for x double dash equals to minus omega square into x. So if I can find any two roots, then the summation of them is going to be general solution. Now that's the whole idea. The same thing I can write it this way. Now the same solution, the same question I am doing it in a slightly different way. So I am just guessing the solution will be of the form c into e power alpha t. Now if x is c into e power alpha t, then x dash will be this much, x double dash will be this much. I will be just substituting it here and I will be cancelling the remaining thing. I will be getting alpha is plus or minus I omega. So alpha is plus I omega is one root, alpha is minus I omega is one root. So x1 will be c1 into e power alpha into t. So alpha is I omega plus I omega into t, c2 into e power minus I omega into t. So the general solution will be summation of these two. But this has to be real. So for this has to be real, c1 and c2 they have to be complex conjugates, right? So c2 equals to c1 dash. Now c1 if I am assuming it as c into e power minus i5, then c2 will be c into e power minus i5, only then summation is going to be real, or these two must be conjugates, right? So when I substitute it, c into e power minus i5, c into e power minus i5, like yeah, this is entire complex thing calculation, right? So e power minus ix plus e power ix plus e power minus ix will be cos 2 cos x, right? So the same thing. So you will be getting this 2c if I call it as amplitude, then you will be getting this as the general solution. The same thing you have got it here also, right? Here instead of writing sine, I could have written cos also. So that's the general solution. Now we will be following the same method. So first of all, let me go for easy questions. So if there is some question like this, then I will be taking general solution as c into e power alpha t. So x dash will be this much, x double dash will be this much. I will be just substituting it back. I will be getting this quadratic. Now what will be the solutions of this quadratic? I will be getting good roots, not imaginary. So first solution will be c1 into e power alpha is minus 1t. The second root will be c2 into e power minus 3t. So the general solution is going to be this plus this. So that's the general solution. But C1 and C2 are two unknowns, so they must be giving two initial conditions for us. So generally, I mean, from the question where I have copied it, they have given initial conditions as x of 0 is 1, x dash of 0 is 0. So when you substitute those two initial conditions, you will be getting C1 and C2, and you will be getting the final solution. Now, if the two roots are equal, now for this question, I will be guessing x equals to c into e power alpha t. So x dash, x double dash, substitute it back, you will be getting a quadratic, you will be getting two equal roots. When there are two equal roots, then one solution will be c1 into e power minus 2t. The other solution can't be c2 into e power minus 2t, it has to be t into c2 into e power minus 2t. These are not damping questions. This is, one is over damping, one is right. So that's the general solution, but you need to get c1 and c2 values. So you need two initial conditions, they will be given in the question, you can say substitute and you can get the answer. Now there won't be SHM in those two cases, there will be SHM only in this case. We will be guessing solution and we will be substituting it, we will be getting two roots, but two imaginary roots. When there are two imaginary roots, like one solution will be this one solution will be this one, but the general solution will be this one. Now yes, one general solution is this one, but summation of these two, it must be real. So for that, C1 and C2 has to be complex conjugates. So I will be just substituting it the same way we have done in SHM thing, right. So you will be ending up somewhere here. Now this one I can write it as this one. So this is the general solution. There are two variables here, c and phi. For that you need to have two initial conditions, which are x of 0 equals to 1, x dash of 0 equals to 1. So if you know the initial conditions, you can find the final solution perfectly, right. Now that's the same thing going to happen here. We got till this equation during the explanation. Now we will see how to solve this equation from the scratch. What we will be doing, we will be guessing the solution. So theta dash, theta double dash, we will be substituting it back. We will be getting a quadratic, we will be getting the solution of the quadratic. So this is one solution, this is the other solution, but the general solution will be summation of these two, summation of these two. Now this must be real, so these two must be complex conjugates. So if C1 is this thing, C2 will be this thing. When I substitute it back, I will be getting this thing. Now instead of expanding this, I can directly have written like it will be of this form, or a sin omega t plus q, I mean b cos omega t form. This will be, because this you will be getting it as cos of something plus phi, right. So cos omega t plus phi, I can write it as a cos omega t plus b sin omega t. That way also I could have written, directly I could have written this thing. Now that's theta, but we need to find exactly. So we need to know the initial values. So two unknowns are there, p and q, or if I want to tell from here that c and phi are unknowns. C and phi unknowns, I converted it into p and q unknowns. The same thing I can write it this way. So, but this is difficult for me to process, so this is easy for me to process for differentiation and stuff. So theta, I know I need to substitute two initial conditions. One is theta, that is at t equals to 0, it is maximum amplitude, and at t equals to 0, omega is 0, and that is theta dash is 0. So theta dash I am finding, so differentiation of this one, this differentiation is going to be this much, this one will remain same, u dash v plus v dash u. So that's the differentiation. Now initial condition, at t equals to 0, you are moving it to the extreme, right. At t equals to 0, theta is extreme, that is delta equals to, now you need to substitute t equals to 0 here, this will be 1, this will be 0, this will be q. 0, sorry, this is 1 into 0 plus q, which will be q is delta. Okay, that is fine. Now theta dash, what is the angular velocity when you leave it? Angular velocity is 0, so this is 0. When you substitute 0, what you will be getting? 0 equals to, this will be minus 5 by 2 into 1, this is 0, this is q, 1, this is 7 by 2 p, this is 0, minus 5 by 2, 0 plus q, 1 into 7 by 2 minus 0. So q value you know delta, so from there you can find p value is 5 by 7 delta. Once you know p value, q value, you can substitute it here to get the solution. So you will be substituting it there to get the solution. From there you will be getting options A and D as correct. Anyway, so that's all, right. Thank you.